Hi everyone, in this video I'm going to explain how the common household fan works. I actually have a fan here that recently stopped working, so I was going to take it apart and I figured why not make a YouTube video. So essentially this is an induction motor. Most household fans use single phase induction motors simply because it's easier to control the speed as opposed to a synchronous motor which operates at a constant speed. So the stator of the motor is actually this outer casing here. You can see the iron core, and from the front view you can actually see the copper windings of the stator connected to the outer part, and the shaft, which is connected to the rotor, this actually spins within the stator. I will explain more of this in a few, but as you can see, the rotor actually won't turn for some reason, or it's very difficult to turn, and I will probably figure out why once I get this open. This is a capacitor, which I will also explain, and this is the switch which controls the speed of the fan and turns it off. This switch is probably a variable resistor which actually limits the current going to the stator, and that limits the speed of the fan itself. So I unscrewed the screws, and this is where things get a little interesting. Take it apart here, and here we can see the stator. This is the stator, which has the stator windings. Note that this is encased in an iron core, and this is the rotor. We can see the rotor windings here, and this rotates within the stator. I was wondering why the rotor was so stiff, but I see now that the rotor is actually connected to a bearing. Here is actually fitted into a bearing in the outer case, and it's very stiff, so I guess dirt or sand probably got in there, and the lubrication probably went dry, so it got stiff and very hard to turn. And from what we can see here, all the connections, the switch, the capacitor, and everything else is connected to the stator. So I will explain how this actually spins. So as I mentioned before, this is an induction motor, and once this is connected to an AC power supply, what will happen is that the copper windings in the stator will become energized and actually produce a magnetic field. This magnetic field will then cut through the windings in the rotor, and the rotor will actually produce its own current, and that current will actually cause the windings in the rotor to actually produce its own magnetic field. So after that, there will be two magnetic fields, one in the stator and one in the rotor, and the reactions between these two will cause the rotor to rotate in the direction of the rotating magnetic field in the stator, simply because the rotor is actually free to rotate about its axis. These stator windings are actually arranged the way they are in order to create a rotating magnetic field, and this is because of the nature of alternating current. When they say that alternating current oscillates back and forth, it means that it oscillates a full 360 degrees, like several times a second. Actually, it actually does that at about 60 hertz, or 60 times per second, or 50 depending on where you live. So for example, let's say this is 0 degrees, 45, 90, 180, 270 and back, and it goes around like this about 60 times per second actually. So the rotor actually spins in this direction or the opposite direction depending on how it's connected at that same speed. But since this is an induction motor, it will actually spin at little less than that speed. Synchronous motors, the rotor will actually spin at the same speed as the rotating magnetic field. So why is a capacitor connected? Well, as we can see here, we have a 5.5 microfarad capacitor connected, and single phase induction motors are not self-starting, meaning that if I were to turn the switch to turn it on, it will not spin up to speed. I would have to manually spin it up for it to get going. And the reason for this is because an AC supply is a sinusoidal wave, and it produces pulsating magnetic fields that is uniformly distributed in the windings of the stator. The pulsating magnetic fields can be assumed as oppositely rotating magnetic fields, which will produce no torque on the rotor. If they're equal and opposite, they're going to cancel each other out, right? Well, this problem has been solved by making the stator windings into two windings, one main winding and an auxiliary winding. The capacitor is connected in series with the auxiliary winding, and when current is supplied through both windings, there will be a phase difference caused by the capacitor, and this phase difference causes a starting torque when the fan is turned on. Pretty much all motors will look similar to this. That's because they all work on Faraday's law of electromagnetic induction, with minor differences when it comes to DC and AC powered motors. There will be some slight differences, but they essentially work the same way. There are a lot of calculations involved in these motors here, but that's another video. So as you can see, this is how it goes. Fits right back in. Screw it up. I actually know why this isn't turning the way it should, and I guess I'll get some WD-40 and just right here to see if it will free up, and maybe I can get this fan working again. So that's it for this video, guys, and I'll see you in the next one.